Good morning to one and all. Today, I'll be taking up some of the important topics in the second chapter, that's the second module titled Direct Kinematics. So the outline of the today's presentation is what are the topics that I am going to discuss today is the robot parameters, the joint parameters, the link parameters, then the kinematic parameter table, then the general link coordinate transformation matrix. How do we attach the coordinate frames to the respective joints of the robot? How to number the joints and links in a robot? How to attach the last coordinate frame to the tip of the gripper? Yeah. So this is the important topics which I'll be covering: the kinematic parameters, then the joint and link parameters, general link coordinate transformation matrix in the today's class. Now, how do we attach the right-handed orthonormal coordinate frames to the various links and joints of the robot arm? So this is the information that this slide gives. See, we all know that a robot arm is made up of links and joints. Each and every joint is a three-dimensional coordinate in a 3D space. Just like how our human hand is made up of bones and joints, a robot arm is also made up of links and joints. Okay. Now, for n-axis robot, so there will be n joints. Then there will be n axis, and there will be n plus 1 3D coordinates, and you have to attach n plus 1 right-handed orthonormal coordinate frames. Those frames will be numbered from L0 to Ln, so that it will be n plus 1. Why we are considering the n plus 1? Because the tip comes into the picture. The tip of the gripper is very, very important. The one frame, the first frame L0 is attached to the base, that is the fixed or the reference. The remaining frames L1 to Ln minus 1 are the mobile. And you are attached to the base, shoulder, elbow, yaw, pitch, roll, etc. etc. Okay. Now, the zeroth coordinate frame is represented by L0, which is equal to x0, y0, z0. It is attached to the end of the link 0, that is the base. The first coordinate frame L1, which is having the axis x1, y1, z1, is attached to the end of link 1. L2 is attached to the end of link 2. L3 is attached to the end of link 3. L4 attached to the end of link 4. Like that. Lk is attached to the distal end of the link. The last coordinate frame, that is the Ln, which is xn, yn, zn, is attached to the tip of the gripper, that is the point P. Okay. Note that the coordinate frames are always attached to the distal end of the links. So zeroth frame, end of link 0. First frame, end of link 1. Second frame, end of link 2. Third frame, end of link 3. Similarly, kth frame, end of link k. Nth frame to the tip of the gripper. As I already told you, for a n-axis robot, how many 3D points are there? There are n plus 1 3D points. But how many axes? N axis means n joints. Okay, so there will be n axis, and there will be n plus 1 3D coordinate. So n for the number of axes plus the last one, the tip of the gripper, that is the point P, so becomes n plus 1. So how do you number them? We number them from L0 to Ln. Okay, out of that only one is fixed, remaining all are mobile in nature. Okay, that fixed is the reference one. Now look at this. For a 6-axis robot, I will consider maximum 6-axis robot, 3 major axes and the 3 minor axes. You can see here L0 is attached to the end of link 0, L1 attached to the end of link 1, L2 attached to the end of link 2, L3 attached to the end of link 3, L4 attached to the end of link 4, L5 attached to the end of link 5. Okay, L6, that is Ln, is attached to the tip of the gripper, which is point P. Okay, from the origin, if you draw a vector to this point P, this will have x-axis, y-axis, z-axis. So out of this L0 to Ln, L6, this is only one frame is a fixed. Remaining L1, L2, L3, L4, L5, L6 are mobile. Because when you rotate the base, each and every point in the 3D space moves. Therefore, it is mobile in nature. So for a n-axis robot, for a 6-axis robot, how many 3D points will be, how many joints will be there? 6 joints. Which are the 6 joints? Base joint, shoulder joint, elbow joint, yaw joint, pitch joint, roll joint, and only 6. Okay, now J1 to J6. How many 3D points will be there? There will be 7 3D points. Out of that 7 3D points, 6 3D points are the dots. and the last steady point is the tip of the gripper. Okay, so there will be 7 right-handed orthonormal coordinate frames or unit frames. Those unit frames are numbered from L0 to L6. Why we are numbered from L0 to L6? Because the last 6 coincides with the axis of the robot. How many axes? 6 axes, so it should coincide with L6. Okay, so that there will be n plus 1 3D coordinates, n plus 1 coordinate frames from L0 to L6. How much L0 to L6? It is 7. So how many kinematic parameters will be there? Each joint will be having 4 kinematic parameters. 1, 2, 3, 4, 5, 6. So 6 into 4 is equal to 24 kinematic parameters. I'll let you know what is this in the next slide. How many links are there? 6 links are there. Link 0, link 1, link 2, link 3, link 4, link 5. The last link, we are calling it as the length of the gripper. In our human sense, in our human context, you can say the length of the fingers. Okay. Now, the joints are always numbered from 1 to n. Okay, J1, J2, J3, J4, J5, J6. Each point is a 3D coordinate. Okay, so there are 7 3D coordinates for a 6-axis robot. So the links are numbered from 0 to n. The last link is called as the length of the gripper. Okay, now you can see that these are the axes: joint 1, joint 2, joint 3, joint 4, joint 5, the tip of the gripper. Right? So understood. For a 6-axis robot, we are attaching 7 frames and there are 6 joints. Now, look at this. Now we will generalize it to a n-axis robot. Now we have taken 6-axis robot. Let me generalize to a 6 n-axis robot. See L0, okay, L1, L2, L3, like that it goes on. Then LK. I'll consider a link K. If this is link K, what is the previous link? Previous link will be LK minus 1. If this is a link K, what will be the next link? It will be length K plus 1. And suppose this is a, always it is told that the links are attached to the distal end of the coordinate frames are attached to the distal end of the links. L0 attached to end of link 0, L1 attached to end of link 1, L2 attached to end of link 2, L3 attached to end of link 3. Similarly, LK attached to the end of link K. Like that. Okay, so that's LK is attached to the end of link K. Last attached to the tip of the gripper. LN is attached to the tip of the gripper. If this is LN, the previous one will be LN minus 1. Understood? How do we attach the coordinate frames to the n-axis robot? So for a n-axis robot, we'll have n joints, n axis, n plus 1 3D points, n plus 1 right-handed orthonormal coordinate frames or unit frames. Okay. Note that the coordinate frames are always attached to the end of the link. So for L0 is attached to the end of link 0, L1 is attached to end of link 1, L2 is attached to end of link 2, L3 is attached to end of link 3. Similarly, LK, you see, look at this, this is LK, is attached to the end of link K. If this is LK, the previous one will be LK minus 1, the next one will be LK plus 1. If this is link K, the previous one will be LK minus 1 and this will be LK plus 1. Okay, this I am considering for the purpose of the analysis. Let me consider to be the link K. So K can vary from anything 1 to 6 or 1 to n. If this is link K, the previous one will be JK minus 1 and this will be JK. Okay, now the future one will be the link K plus 1 and this will be link K minus 1. Note that a joint JK connects link K and link K plus 1, whereas a joint JK minus 1 connects link K minus 1 and link K, or a link K connects joint JK minus 1 and JK. Okay, with this concept in mind, so I will go to the next slide. Look at this. A link K connects joint JK and JK plus 1. So a link K connects joint JK and JK plus 1, whereas joint JK connects link K minus 1 and link K. Joint JK connects link K minus 1 and link K. Okay, a joint JK connects link K minus 1 and link K, whereas the link K connects joint JK and JK plus 1, because the joints are numbered from 1 to n and the links are numbered from 0 to n to coincide with the axis of the robot. So understood? So a joint JK connects link K minus 1 and link K. Okay, whereas a link K connects joint JK and JK plus 1. Why it is so? Because the joints are numbered from 1 to n. N coincides with the axis of the robot. Okay, this Look at this. We will see how to attach the coordinate frames. Okay, L0 is attached to the end of link 0, L1 is attached to the end of link 1, which is shoulder, L2 is attached to the end of link 2, which is nothing but elbow, L3 attached to the end of link 3, which is the yaw, like this, link 4, link 5. The last one is called the length of the gripper. Okay, this is called the tip of the point, the tip of the gripper, which is very important. So out of this, only first frame is a fixed, L0 is fixed, remaining all are mobile in nature, because when you rotate the base, this entire arm rotates in the 3D space. So when you are moving your human hand, when you are moving your hand in the 3D space, what is happening? Only your body is fixed, stationary. So this is stationary. Your entire arm is moving in the 3D space. For example, when you are dancing, what happens? Entire hand is moving in the three-dimensional space. So shoulder, elbow, yaw, pitch, roll, and the finger points all are moving in the 3D space. That thing you should remember. Okay, now so this is a six axis robot: base, shoulder, elbow, yaw, pitch, and the roll. So joints are numbered from J1, J2, J3, J4, J5, J6. The last one is not a joint, it is a tip of the gripper. So how many this one? So it is six axis. So since it is six axis, we are having seven frames, L0 to L6. So it coincides with seven three-dimensional frames. Okay, now there's one important point to be remembered. That point is, look at that. From the origin, if I draw a vector to the point P, this point P will be having x-axis, x projection, y projection, and the z projection. Okay, this is all what is called as mapping the coordinates. I'll let you know at the end of the class. Okay, so this is 6. So I'll map from 6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1, and 1 to 0. Okay, that is the what do you call as mapping of the coordinates. This is a transformation matrix which maps the coordinates from one frame to another frame. T6 to 5 maps the coordinates from 6 to 5. T5 to 4 maps the coordinates from 5 to 4. See this 4 to 3, 4 to 3. Then 3 to 2 maps the coordinates from this to this. Like that it goes on. Now there are certain rules how to attach the coordinate frames. Like I already told you that in the previous slides, the coordinate frames are attached to the distal end of the links, that is the end of the link. L0 end of link 0, L1 end of link 1, L2 end of link 2, L3 end of link 3, like that. Ln end of the link n, which is nothing but the length of the gripper. Now when you attach the last coordinate frame, you cannot assign as and you like. There are certain rules for how to attach a last coordinate frame. That last coordinate frame has to be attached according to certain rule. That rule is what is called as how to attach the last coordinate frame. I'll show you that one. How to attach the last coordinate frame to the tip of the gripper. Take for example, this is the length of the gripper. This is our human wrist. Okay, this is our human wrist. This is our human wrist. Correct? Now, this human hand is going to pick up an object. Similarly, this human hand is going to pick up an object. Where is the object? Object is here. So this human hand is approaching the object. Similarly, this human hand is approaching the object. The brain is giving a signal to pick up the cup of juice. Okay, similarly the brain is giving the instruction to the wrist to pick up this object. So our human hand is approaching the object. Look at this. This is a gripper which is approaching the object, which is going to pick up an object. Okay, so this is the wrist. If this is the wrist, this is the length of the gripper, similar to our human hand, the length of the fingers. So the length of the gripper, that is what is called the last Ln. Now look at this, how you have to attach. There are certain rules. Now there are three important points in how to attach the last coordinate frame. Ln consists of xn, yn, and zn. Okay, now out of that, the first vector which you have to attach is Zn. How will you attach Zn? Zn has to be attached in such a way that you have to attach in the direction in which the gripper is pointing. So if the gripper is pointing in this direction, so attach the Z axis in this direction. Now look at the human hand is pointing in this direction, so attach the Z axis in this direction. So the human hand is pointing in this direction, attach the Z axis in this direction. So the gripper is pointing in the downward direction, attach the Z axis in this direction. Now You attach the z axis. Now you have to attach the y axis. The rule is z, y and x. First z you attached. How? In the direction in which the gripper is pointing. Next to y has to be assigned in such a way that it is assigned along the open close axis of the gripper. Now look at this. When you want to keep this object on the table, you keep it and you open your fingers, correct now? And you want to pick it up, you close the fingers. So that is the open close axis. Y axis, it has to be assigned along the open close axis of the gripper. That is what is called the sliding vector. That means the fingers slides in or slides out. Suppose if the object is here, okay, so what will you do? The two fingers will close, slide in. Now you have to place the object, so you open it, so the fingers open. Opening, closing. When you are closing, to pick up. When you are opening, to keep it up on the table. These are the instructions that the brain is giving to the human hand. Similarly, how will you give it to the machines? So this is how you have to give it to the machines. So the robot is approaching the object. Immediately if I tell pick up the object, human hand will go and pick up the object. But if a machine is there, how will it pick up? So much mathematical analysis has to be done. That mathematical model has to be given to the robot. Then the robot will go and pick up the object. Okay. Now you attach Z in the direction which the gripper is pointing. Now you are assigned Y along the open close axis of the gripper. Now perpendicular to this, you attach the normal vector. Normal means it is perpendicular. You know that Z cross Y is equal to Z. Cross product of two vectors gives you a third vector. Understood? Okay. This is how we are going to assign the last coordinate frame. So the last coordinate frame is assigned along the direction in which the this z is assigned along the direction in which the gripper is pointing. Y is assigned along the open close axis of the gripper. Perpendicular to this, you are attaching the normal vector. This is how you attach the last coordinate frame to the tip of the gripper. Okay. Now this I have written in sentences. Attach a vector called as Zn is equal to r cube, which is called as approach vector in the direction which the gripper is pointing, and it corresponds to the third column of the composite rotation matrix. Why it is called as approach vector? Because the gripper is approaching the object. Now attach a vector called as yn, that is equal to r2. We can call it as a sliding vector. Why it is called a sliding vector? Because the open close axis of the gripper, and this corresponding to the pitch or the second column of the composite rotation matrix. It is called a sliding vector because the fingers will slide in and slide out. When it will slide in, to pick up the object. When it will slide out, to place the object. Object table ಮೇಲೆ ಇಟ್ಬಿಟ್ಟು ಆದ್ಮೇಲೆ fingers open ಮಾಡ್ತಿರಲ್ಲ, that is called as slide out. Now, attach a vector called as xn, which is perpendicular to the sliding and approach vector, and this corresponds to the ya, or the first column of the composite rotation matrix. Why it is called as normal vector? Because it is normal or perpendicular to both sliding and the approach vector. So till now, what did you study? You studied how to attach the coordinate frames to the respective joints of the robot arm. Suppose if it is a 6-axis robot, you will be attaching 7 coordinate frames because there are 7 3D points. And for a 6-axis robot, how many joints are there? There are only 6 joints. Okay, so with this in mind, okay, the last coordinate frame has to be assigned according to some rule, according to that thumb rule they call. So this is according to that thumb rule. Okay, now the next important point is, we know that robot is there are two types of robots: stationary robot and a mobile robot. Stationary robots are called as fixed robotic manipulators. If the arm is mounted on a vehicle, then it becomes a mobile robot. Now in general, what is a robot made up of? Robot is made up of links and joints. These links are nothing but bones. Our human hand is made up of what? Human hand is made up of bones and joints. Okay, so there are two types of joints. Which are those two types of joints? One joint is a rotary joint where theta is a variable. We get the one joint is a rotary joint, which is a theta is a variable. Here we get two robo parameters. I'll let you know what it is. Then translatory joint, D is the variable. We get two robo parameters. Totally, we get four robo parameters. Robotic parameters or the kinematic parameters they call. Okay. Now, if I take human hand, samjho this is our human hand. Okay, so base is here, shoulder is there, elbow is there, wrist here. So what is varying in between elbow, shoulder, and the wrist? Theta. Theta is varying, na? So similarly, so link. How do you differentiate between a link? I told you, na, a robot is made up of links and joints. What is a joint? A joint is a junction which connects two successive links. Okay, and it is a point around which the two links will rotate with respect to each other, or the two links will translate with respect to each other. That's the definition of a joint. I told you two types of joints are there: rotary joint and a translatory joint. So what is a joint? A joint is nothing but a junction at which the two links are connected together, or a junction which connects two successive links, or a point around which the two links will rotate with respect to each other or translate with respect to each other. Suppose if I take this to be the elbow. See, if I take the elbow, upper arm and the lower arm. Okay, lower arm is from elbow to wrist. Upper arm is nothing but shoulder to the elbow. Okay, so the elbow, with respect to the elbow, to the two upper arm and the lower arm will be moving in and out. Similarly, that one. As a result of which we get two motions. One is a rotary motion, one is a translatory motion, moving in a straight line, moving in a rotate angle theta. So how do you define link? Link is nothing but a rigid member which is connected between two successive joints. A joint is a junction which connects two successive links. A link is a rigid member which connects two successive joints. Okay, as a result of which we get two types of motion. One is a rotary motion, one is a translatory motion. How do you obtain a rotary motion? By making use of a motor. Alright, so the variable is angular displacement. Then the another, how do you obtain a prismatic motion or a linear motion? By making use of a piston. So the variable is a distance, the variable is theta. This is a motor. Okay, ಇದಕ್ಕೆ energize ಮಾಡಿ actuation ಮಾಡಿ plus or minus 5 volts or 12 volts ಕೊಡಿ to 30 volts. What will happen to the shaft? The shaft will start rotating either in the clockwise direction or in the anti-clockwise direction. Take a piston. Okay, really there is a piston is nothing but there will be inlet for the fluid to go, inlet outlet for the fluid to come out. Okay, so this piston will move in and out. How? Suppose if admit pressurized fluid or pressurized air, it oozes out between this space. ಇದ್ರ ಮಧ್ಯೆ ಈ ಟಿ ಜಾಯಿಂಟ್ ಇದೆಯಲ್ಲ ಮೇಲ್ಗಡೆ ಕೆಳಗಡೆ ಗ್ಯಾಪ್ ಇರ್ತದೆ, ಆ ಗ್ಯಾಪ್ ಒಳಗೆ ಹೋಗ್ಬಿಟ್ಟು it will come out, as a result of which the fluid or the air pushes this, so it moves that side. On the other hand, if you admit pressurized fluid in this direction, the piston moves in this direction from the left to the right, as a result of which we get a linear motion. Okay, so a robot arm is made up of links and joints. Okay, a rotary joint theta is a variable, the translatory joint d is a variable. Here this gives you the difference between a joint and a link. Okay, I have correlated the human and the this one. Now look at this. This is a human hand. I told you that ಅಲ್ಲಿ ಜಾಯಿಂಟ್ ಗೆ ಎರಡು ಪ್ಯಾರಾಮೀಟರ್ ಬರುತ್ತೆ, ಲಿಂಕ್ ಗೆ ಎರಡು ಪ್ಯಾರಾಮೀಟರ್, ಟ್ರಾನ್ಸ್ಲೇಟರ್ ಗೆ ಎರಡು ಪ್ಯಾರಾಮೀಟರ್ ಬರುತ್ತೆ ಅಂದಿದೆ. ಅದೇನು ಹ್ಯೂಮನ್ ಹ್ಯಾಂಡ್, ಶೋಲ್ಡರ್, ಎಲ್ಬೋ, ರಿಸ್ಟ್ ಇರ್ತದೆ. Okay, now there theta is a variable, joint distance is another variable. Distance of the joint you might get confused because there is only eki joint, only one joint is there. From where will you get distance? Distance will get, look at this is link 1, link 2, link 3, similar to a human hand, one ದಂಡು ಇನ್ನೊಂದು ದಂಡು. Okay, so this is the point. Okay, for example, if you take one scale, if you take one scale, another scale ಮಧ್ಯೆ ಒಂದು ನಟ್ ಬೋಲ್ಟ್ ಹಾಕ್ಬಿಟ್ಟು ಟೈಟ್ ಫಿಟ್ ಮಾಡ್ತೀರಾ, ಅದು ಲೂಸ್ ಆಗಿರುತ್ತೆ, and these two links will rotate with respect to each other. Correct na? You take one link or mini drafter ತಗೊಳ್ಳಿ, ಒಂದು ಲಿಂಕು ಅನದರ್ ಲಿಂಕು ಮಧ್ಯೆ ಒಂದು ಹೋಲ್ ಹಾಕ್ತೀರಾ, ಹೋಲ್ ಹಾಕ್ಬಿಟ್ಟು ಒಂದು ಇಲ್ಲಿಂದ ಒಂದು ನಟ್ ಬೋಲ್ಟ್ ಪಾಸ್ ಮಾಡಿಬಿಟ್ಟು ದಿಸ್ ವಿಲ್ ಬಿ ದ ಆಕ್ಸಿಸ್, ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿಸ್ ಆಕ್ಸಿಸ್ ದಿಸ್ ಲಿಂಕ್ ವಿಲ್ ರೊಟೇಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿಸ್ ಆರ್ ವೈಸ್ ವರ್ಸ. ಸೊ ದ ವೇರಿಯಬಲ್ ಇಸ್ theta. So this is the joint axis. Okay, now for example if I take one, ಇದು ಒಂದು ಪೆನ್ ತಗೊಳಪ್ಪ, ಇನ್ನೊಂದು ಪೆನ್ನು, ಒಂದು ಪೆನ್ನು ಇನ್ನೊಂದು ಪೆನ್ನು, ಸೊ ಎರಡು ಜಾಯಿನ್ ಮಾಡಬೇಕು. ಹೆಂಗ್ ಮಾಡ್ತೀರಾ? ಮಧ್ಯೆ ಒಂದು ತೂತ್ ಕೊಡೋದು, so we'll put a nut and a bolt. Now you take the center point of this one pen, center point of the another pen. Okay, that distance is what is called as a joint. ಇಲ್ಲಿ ನೋಡೋದಕ್ಕೆ ಒಂದೇ ಜಾಯಿಂಟ್ ತರ ಕಾಣಿಸುತ್ತೆ, ಕರೆಕ್ಟ್ ತಾನೆ? ಒಂದೇ ಜಾಯಿಂಟ್ ತರ ಕಾಣಿಸುತ್ತೆ, ಬಟ್ ಇಟ್ ಈಸ್ ಸ್ಮಾಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ದೇರ್, ಬಟ್ ದಿಸ್ ಇಸ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ಫಾರ್ ಅ given robot. Only the variable is theta in nature. ಈ ಜಾಯಿಂಟಿಗೆ ಒಂದು ಮೋಟರ್ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೀವಿ, ಈ ಜಾಯಿಂಟಿಗೆ ಒಂದು ಮೋಟರ್ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಅಂಡರ್ಸ್ಟುಡ್ ವಾಟ್ ಈಸ್ ಜಾಯಿಂಟ್ ಡಿಸ್ಟೆನ್ಸ್? ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಸ್ಮಾಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಒನ್ ಪೆನ್ ಅಂಡ್ ಅನದರ್ ಪೆನ್. ಇದು ಎಲಿವೇಶನ್ ಫ್ರಮ್ ದಿಸ್ ಸೈಡ್ ಇಂದ ತಗೊಂಡಿದ್ದೀನಿ. ಸೊ ದ ಒನ್ rectangle, another one rectangle, in between this small distance. Theta is the variable. if I take one example, say fan. One fan is like this, so this is rotating like this, so this is fan axis. I'll take another fan. Okay, that second fan is also hung in the ceiling, so its axis is vertical. With respect to this, it is rotating clockwise or anti-clockwise. So what is the angle between the two joint axes? This joint axis is like this joint axis is like this. So the angle between the two joint axes is zero because the joint axes are parallel. That angle is called as a link twist angle. What is link twist angle? Link twist angle is the angle between the joints axis. This is axis 1, axis 2. What is the angle between the two joint axes? That is called as a link twist angle. Okay. Now I'll take one fan, ceiling fan. So it is like this, vertical. So what is the fan axis? Vertical. With respect to vertical, it is rotating like this. Now I take a table fan. This table fan is kept like this, okay, on the table. So the fan is rotating like this. Okay, so what is the axis? Axis is like this. Now we ನೋಡಿ ಈ axis ಹಿಂಗಿದೆ, ಈ axis ಹಿಂಗಿದೆ. Okay, so what is the relationship between the two joint axes? It is perpendicular, na? So I can take it as plus or minus 90 degrees. So the angle between the two joint axes is plus 90 or minus 90. That angle is what is called as the link twist angle. Link twist angle andre angle between the two joint axes. The two joint axes can be parallel or the two joint axes can be perpendicular. Okay, that is what is called as the link twist angle. Okay, now let us come to kinematic parameters. What are kinematic parameters? Kinematic parameters are defined as the parameters which are associated with the kinematic configuration of the robot arm. Kinematic configuration andre serial chain manipulators. That is a joint to linko, joint to linko, joint to linko. One end is fixed, other end is open, free, gripper attach ಮಾಡಿರ್ತಾರೆ. That is called as the kinematic configuration. Snake ತರ. Okay, plastic snake ತರ. So how do you define kinematic parameters? Kinematic parameters are defined as the parameters which are associated with the kinematic configuration of the robot arm. See, we know that robot arm is made up of links and joints. Therefore, kinematic parameters are divided into joint parameters and link parameters because a robot is made up of links and joints. So link ಗೆ ಎರಡು parameter ಬರುತ್ತೆ, joint ಗೆ ಎರಡು parameter ಬರುತ್ತೆ. Joint parameters are always defined with respect to the z axis, with respect to the axis with which it is rotating. Link parameters are always defined with respect to the x-axis. How many types of joint parameters are there? Two types. One is called as a joint angle, another is called as a joint distance. How many types of link parameters are there? Two link parameters. One is called as a AK, another is called as a alpha k. So you mug-up ಮಾಡ್ಬಿಡ್ಬೇಕಿದು joint angle theta k, joint distance dk, link length ak, link twist angle ak. Link length ಅಂದ್ರೆ length of the link. Link twist angle ಅಂದ್ರೆ ನಾನು ಹೇಳಿದ್ನಲ್ಲ ಅಲ್ಲಿ angle between the joint axis. The joint angle theta ಅಂತ ಕೇಳಿದ್ನಲ್ಲ, suppose your elbow, your human hand elbow is moving up and down, so what is varying? Theta is varying. Joint distance is angle between that small joint, that dk, small pen ಎರಡು ತೋರಿಸಿದ್ನಲ್ಲ, that is. So kinematic parameters are defined as the parameters which are associated with the kinematic configuration of the robot arm. And since the robot arm is made up of joints and links, kinematic parameters are divided into two types. One is called as joint parameters and it's called as the link parameters. Joint parameters are theta k and dk, link parameters are ak and alpha k. Joint parameters are always defined with respect to z axis, link parameters are always with respect to x axis, as a result of which kinematic parameters are four in number, two joint and two link. So with this in mind, we'll go up to the explanation of what are joint parameters and the link parameters. First, I will take up joint parameters. Now, joint parameters. Joint parameters, I already told you, they are associated with the joint. They are always defined with respect to the z-axis. What are they? They are called as theta k and dk. You ಎರಡು ಬರ್ದಿದ್ದೀವಿ definitions ಇದೆಯಲ್ಲ, ಇದು thumb rule. This is the theorem of robotics ತರ. So you have to mug it up. ಓಕೆ, ಸೊ ಮಗಿಟಪ್ ಅಂದ್ರೆ ಏನು? ನೀವು ನೀವು ಚಿಕ್ಕ ಹುಡುಗರಾಗಿದ್ದಾಗ ಸ್ಕೂಲು ಕಾಲೇಜಲ್ಲಿ ಟೀಚರ್ಸ್ ಬೋರ್ಡ್ ಮೇಲೆ ಬರೀತಿದ್ದ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ. ನೀವು ಏನು ಮಾಡ್ತಿದ್ರಿ? ಟೀಚರ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂದಾಗ ನೀವು ಅದು ಇಂಟು ಮಾರ್ಕ್ ಹಾಕ್ಬಿಟ್ಟು 4 ಡಾಟ್ ಹಾಕ್ಬಿಟ್ಟು VVIP ಎಕ್ಸಾಂಪಲ್ ಬರುತ್ತೆ ಅಂತ ಹಾಕಿರ್ತೀರಿ. ಅದೇ ಅವ್ರ ಟೀಚರ್ ಹೇಳ್ತಾರೆ ಫಾರ್ಮುಲಾ ಎಲ್ಲ ಮಗಪ್ ಮಾಡ್ಬೇಕಪ್ಪ, ಬಯಾಟ್ ಮಾಡಬೇಕು, ರಟ್ ಮಾಡಬೇಕು ಅಂತೇಳಿ. ಅವಾಗೇನು, ಅವಾಗ ಒಂದು ಸ್ಟೂಡೆಂಟ್ ವಾಸ್ ರೈಟಿಂಗ್ ಲೈಕ್ ದಿಸ್. ನಾನು ಒಂದಿನ ಅದೇ ಹಾಕ್ದೆ. ಫಾರ್ ಎವ್ರಿ ಟೈಮ್ ಐ ಯೂಸ್ ಟು ಟೆಲ್ ದಿಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾ, ಯು ಟು ಮಗ್ ಇಟ್ ಅಪ್, ಬಯಾಟ್ ಮಾಡಬೇಕು ಅಂತ. ಅಂತ. ಆ ಹುಡುಗಿ ಹಿಂಗೆ ಬರೀ ಕಪ್ ಪ್ರತಿಯೊಂದಕ್ಕೂ ಕೆಲವರೆಲ್ಲ ಹಿಂಗ್ ಬರ್ಕತಾ ಇದೆ, ಆ ಹುಡುಗಿ ಹಿಂಗ್ ಬರ್ಕತಾ ಇತ್ತು. ಕಪ್ ಏನು ಸರ್ ಇದು ಯಾಕಪ್ಪ ಹಿಂಗ್ ಬರ್ಕಂತ ಇದೆ ಸರ್, ನೀವು ಹೇಳಿದಲ್ಲ ಸರ್ ಮಗಪ್ ಮಾಡಬೇಕು ಬಯಾಟ್ ಮಾಡಬೇಕು, ಮಗ್ ಇಟ್ ಅಪ್ ಅಂದ್ರೆ ಮಗ್ ಇದು ಕಪ್ಪು, ಮಗ್ ಇಟ್ ಅಪ್ ಮೇಲೆ ಎತ್ಕೋಬೇಕು ಅಂತ ಹೇಳಿ. Some students write like that and some students write like this. So these two theorems here to mug it up. What is that? Joint angle theta k is defined as the rotation about zk minus 1 needed to make xk minus 1 parallel or aligned with xk. So this is defined in two ways, either parallel or aligned. Once again I'll define. Joint angle theta k is defined as the rotation about the zk minus 1 needed to make xk minus 1 parallel or aligned with xk. On the other hand, theta k can also be defined as the angle from xk minus 1 to xk. Okay, that is called as theta k is the angle of the kth joint. Now, joint distance. How do you define joint distance? It is a translation along zk minus 1 needed to make xk minus 1 intersect or aligned with xk. I'll repeat. Translation along zk minus 1 needed to make xk minus 1 intersect or aligned with xk. So this is also defined in two ways. One is aligned, another is intersect. So this can also be defined as the distance from xk minus 1 to xk, or it can also be called as a dk is the distance between the center point of the links. ಅಲ್ಲಿ ತೋರಿಸಿದ್ನಲ್ಲ ಎರಡು ಪೆನ್ ಇಟ್ಬಿಟ್ಟು ಆ ಎರಡು ಚುಕ್ಕೆ ಪಕ್ಕ ಪಕ್ಕ, that is dk. Or it is the dk is the distance between the joints along the kth joint axis. This is called as offset. Constant ಇರುತ್ತೆ for a given system. Okay. So for every joint parameter, only one joint parameter is fixed, the other is variable. So for theta k, for rotary joint, what is the variable? Theta is the variable, and d is fixed. For prismatic joint, what is the variable? Distance is variable and theta is fixed. So remember, istuna you mug it up, ಮಾಡಬೇಕು by heart. What is that? Again I'll repeat it what it is. Theta k and a joint angle. So joint angle is defined as the rotation about zk minus 1 needed to make xk minus 1 parallel or aligned with xk. dk ಅಂದ್ರೆ translation along zk minus 1 needed to make xk minus 1 intersect or aligned with xk. These are IEEE definitions, thumb rules. ಏನು ಮಾಡಕ್ಕಾಗಲ್ಲ. Any robotics textbook you open, you'll get the same definitions. Okay, so these are with respect to the joint parameters. ಅರ್ಥ ಮಾಡಿಸ್ತೀನಿ ಹೆಂಗೆ ನಿಮಗೆ. How do you get theta k? How do you get dk? In two ways. Look at this. This is the diagrammatic representation of the joint parameter. Okay, now I already told you link k connects joint jk and jk plus 1 ಅಂತ ಹೇಳಿದ್ನಲ್ಲ ಅದು. Link k, so link k connects joint jk and jk plus 1. So previous one lk minus 1 is the link k. What is lk having? Lk is having axis xk, yk and zk. If this is lk, the previous one will be lk minus 1. Lk minus 1 will be having axis xk minus 1, yk minus 1 and zk minus 1. Already previous slide ಅಲ್ಲಿ ಹೇಳಿದ್ನಲ್ಲ, what is theta k? Angle between the two x-axis. Angle from xk minus 1 to xk is called the angle from xk minus 1 illide ingide, xk ingide. So that angle is what is called as a theta k. Theta k is the angle from xk minus 1 to xk. This is the diagrammatic representation of joint parameters. ಈ theta k ಅಂದ್ರೆ ಈ ಜಾಯಿಂಟ್ಗೂ ಈ ಜಾಯಿಂಟ್ಗೂ ಒಂದೇ ಜಾಯಿಂಟ್ ಇದು, ಯಾಕೆ ಪಕ್ಕ ಪಕ್ಕ ಇರ್ತದೆ, ಬಿಕಾಸ್ ಮೆಕ್ಯಾನಿಕಲ್ ಅಲ್ವಾ. ಸೊ ಅದಕ್ಕೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಎ ಡಿ ಕೆ. ನಾವು ದಿಸ್ ಡಿ ಕೆ ಆಯ್ತು ತೋರಿಸಿದ ಎರಡು ಪೆನ್ ಇಟ್ಬಿಟ್ಟು ದಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ಸೆಟ್ ಅಂತಾರೆ ಇದಕ್ಕೆ. ಓಕೆ, ನಾವೀಗ ಒಂದು ಪೆನ್ ತಗೊಂತೀರಪ್ಪ, ಒಂದು ಪೆನ್ನು ಇನ್ನೊಂದು ಪೆನ್ನು ಜಾಯಿಂಟ್ ಮಾಡ್ಬೇಕು, ಏನು ಮಾಡ್ತೀರಾ, ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಹೋಲ್ ಹಾಕ್ಬಿಟ್ಟು ನಟ್ಟು ಬೋಲ್ಟ್ ಟೈಟ್ ಮಾಡ್ತೀರಾ. ಯು ಟೇಕ್ ದ ಸೆಂಟರ್ ಪಾಯಿಂಟ್ ಆಫ್ ಒನ್ ಪೆನ್, ಸೆಂಟರ್ ಪಾಯಿಂಟ್ ಆಫ್ ಅನದರ್ ಪೆನ್, ದಟ್ ಡಿಸ್ಟೆನ್ಸ್ is called as the offset. Okay, now keeping this in mind, we'll define what is I'll define what is theta k. The rotation about zk minus 1 needed to make xk minus 1 parallel with xk. Correct na? Ange what is that same definition you have to mark it. This is in the three dimensional plane ಮಾಡಿದೀನಿ ನೋಡಿ. What is the three dimensional plane? ನೋಡಿ, ಮೇಲ್ಗಡೆದು xk yk zk ಇತ್ತು. This is the same joint. Always z axis, sorry, joint parameters are defined with respect to the z axis. Okay, ಇದು ಹಿಂಗೆ xk minus 1 ಇದೆ, ಇದು yk minus 1 ಇದೆ, ಇದು zk minus 1 ಇದೆ. This is the joint distance dk. This is the angle theta k. Joint parameters are always defined with respect to the z axis. That means one joint axis ಹಿಂಗಿರುತ್ತೆ, ಹಿಂಗಿದ್ರೆ ಇನ್ನೊಂದು ಜಾಯಿಂಟ್ ಆಕ್ಸಿಸ್ ಹಂಗೆ ಇರಬೇಕು. ನೋಟ್ ದಟ್ ದಿ z is always defined along the z axis. See, the joint axis is always along the x axis. For example, ಇದು ಫ್ಯಾನ್ ಹಿಂಗ್ rotate ಆಗ್ತಾ ಇದೆಯಲ್ಲ, so along that fan only, fan axis, we have to put that zk. So this is the diagrammatic representation for joint parameters in the three-dimensional view. Look at this. ಇದರಲ್ಲಿ ಎರಡು ಮೆಥಡ್ ಹೇಳಿದ್ನಲ್ಲ, ಅಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟು, ಅಲೈನ್ಡು, ಪ್ಯಾರಲ್ಲು ಅಂತ. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಜಾಯಿಂಟ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಡಿಫೈನ್ಡ್ ಇನ್ ಟೂ ವೇಸ್. ಲುಕ್ ಅಟ್ ದಿಸ್. ಫಸ್ಟ್ ಡೆಫಿನಿಷನ್, ಐ ವಿಲ್ ಫಸ್ಟ್ ನಾನು ರೊಟೇಟ್ ಮಾಡ್ತೀನಿ, ಆಮೇಲೆ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡ್ತೀನಿ. ಇದು ಮೇಲ್ಗಡೆದು ಎಲ್ ಕೆ, ಕೆಳಗಡೆದು ಎಲ್ ಕೆ ಮೈನಸ್ ಒನ್. ಎಲ್ ಕೆ ಮೈನಸ್ ಒನ್ ಅಂದ್ರೆ ಫ್ರೇಮ್. ಎಲ್ ಕೆ ಮೈನಸ್ ಒನ್ is having x k minus 1, y k minus 1, z k. L k is having x k, y k, z k. Note that z axis of this z k of L k, z k minus 1 of L k minus 1, both should be aligned along the same axis. Now ಈಗ ನೋಡಿ, ಈ ಮೇಲ್ಗಡೆಯಿಂದ ಈ ವೆಕ್ಟರ್ನ ಇಟ್ಕೊಂಡು ನಾನು ಹಿಂಗೆ ತಿರುಗಿಸ್ತೀನಿ. Okay, by an amount equal to theta k. If I rotate by an amount equal to theta k, what happens? X k minus 1 will come here, y k minus 1 ಹಿಂದೆ ಹೋಗುತ್ತೆ ಮೇಲ್ಗಡೆಯಿಂದ ಅಲ್ವಾ. Look at this. What did you do? You rotated this frame by an amount equal to theta k, so that x k minus 1 became parallel to x k. That is the definition of theta k. How do you define theta k? Theta k is defined as the rotation about z k minus 1. The rotation about z k minus 1 needed to make xk minus 1 parallel to xk. By how much amount? You should rotate this one so that this and this will get parallel by an amount equal to theta k. ಗೊತ್ತಾಯ್ತಲ್ಲ? Again I'll repeat. So how do you define theta k? Theta k is a joint angle. Okay, it is defined as the rotation about zk minus 1 needed to make xk minus 1 parallel to xk. So if I rotate by an amount equal to theta k, xk minus 1 and xk will become parallel. ಇದನ್ನ ಮೇಲ್ಗಡೆಯಿಂದ ತಿರುಗಿಸಿ by how much amount equal to theta k, ಅವಾಗ this and this will become parallel. Okay, that is the definition of theta k. So after you complete theta k, what happens? Xk minus 1 will become parallel to xk. Correct? ಎರಡು parallel ಆಗೋಯ್ತು. That operation is with respect to which axis? Z axis. So it is given by a fundamental homogeneous coordinate rotation matrix about the Z axis. Now let me define dk. ಈಗೇನ್ ಮಾಡು, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡ್ಬಿಡು by an amount equal to dk. So how do you define dk? Dk is defined as the translation along zk minus 1 needed to make xk minus 1 aligned with xk. My main thing is I want to make this and this aligned. Okay, how will you align? You translate. ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೂ ನೀವು ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಈ ಫ್ರೇಮು ಮರ್ಜ್ ಆಗುತ್ತೆ. ಕರೆಕ್ಟಾ? ನೋಡಿ ಇಲ್ಲಿ ಇದು ಮೇಲ್ಗೆ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿದ್ನಲ್ಲ, ಬೈ ಹೌ ಮಚ್ ಅಮೌಂಟ್ ಈಕ್ವಲ್ ಟು ಡಿ ಕೆ. ಸೊ ದಟ್ ಎಕ್ಸ್ ಕೆ ಅಂಡ್ ಎಕ್ಸ್ ಕೆ ಮೈನಸ್ ಒನ್ ಅಲೈನ್, ವೈ ಕೆ ಮೈನಸ್ ಅಲೈನ್, ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಅಲೈನ್. ಸೊ ಹೌ ಡು ಯು ಡಿಫೈನ್ ಡಿ ಕೆ? ಡಿ ಕೆ is defined as the translation along zk minus 1 needed to make xk minus 1 aligned with xk. Got it? Now after you perform dk, what is happening? Xk minus 1 get aligned with xk. Now this is the first way of defining. How did you define theta k? Theta k is first to rotate ಮಾಡ್ಬಿಟ್ಟು ಆಮೇಲೆ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿ, ಉಲ್ಟಾನು ಮಾಡಬಹುದು. Okay, and then next slide ಅಲ್ಲಿ ತೋರಿಸ್ತೇನೆ ನಾನು. So theta k is defined as the rotation about zk minus 1 needed to make xk minus 1 parallel with xk. How do you define theta dk? Dk is defined as the translation along zk minus 1 needed to make xk minus 1 aligned with xk. After you perform theta k and dk, the two frames lk and lk minus 1 merges. Okay, this is one way of defining. Now this corresponds to one screw transformation. What is screw transformation? Rotation and translation with respect to the same axis, that is z axis. Now I first rotated and then translated. Now I'll go the ulta way. I'll first translate and then rotate. Look at this. This frame is like this. This frame is like this. That is the diagrammatic representation of the joint parameters. Now again mado ಮೊದಲೇ translate ಮಾಡ್ಬಿಡು. I will translate along this side. Suppose if I translate this frame by an amount equal to dk, what will happen? xk minus 1 will intersect with xk. Correct na? So how do you define dk? Dk is defined as the translation along zk minus 1 needed to make this xk minus 1 intersect with xk. So once I do the translation by an amount equal to dk, xk minus 1 will get intersected with xk. Now ಏನು ಮಾಡಿ ನಾನೀಗ next rotate ಮಾಡ್ತೀನಿ. Now I'll rotate about like this by an amount equal to dk. Now how do you define theta k? Theta k is defined as the rotation about zk minus 1 needed to make xk minus 1 aligned with xk. ಕರೆಕ್ಟ್ ನಾ? ಸಿ ನೋಡಿ ಗ್ರೀನ್ ಕಲರ್ ಫ್ರೇಮ್ ಇದೆ, ಈ ಝೆಡ್ ಕಲರ್ ರೆಡ್ ಕಲರ್ ಫ್ರೇಮ್ ಇದೆ. ಎರಡು ಅಲೈನ್ಡ್ ಆಗ ಯಾವಾಗ ಆಗುತ್ತೆ? ಈ ವೆಕ್ಟರ್ ಇಲ್ಲಿಗೆ ಬಂದು ಈ ವೆಕ್ಟರ್ ಹಿಂದಕ್ಕೆ ಹೋದ್ರೆ ಅವಾಗ ಬೈ ಯು ರೊಟೇಟ್ ಬೈ ಅನ್ ಅಮೌಂಟ್ ಈಕ್ವಲ್ ಟು ಥೀಟಾ. ಈ ಮೇಲ್ಗಡೆಯಿಂದ ಥೀಟಾಕ್ಕೆ ರೊಟೇಟ್ ಮಾಡಿ. ಇಫ್ ಐ ರೊಟೇಟ್ ಅಬೌಟ್ ಥೀಟಾಕ್ಕೆ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ಎಕ್ಸ್ ಕೆ ಮೈನಸ್ 1 ವಿಲ್ ಕಮ್ ಇಯರ್, ವೈ ಕೆ ಮೈನಸ್ 1 ಅದ್ರಿಂದ ಹೋಗುತ್ತೆ. ಹಾಗೆ ಮೇಲ್ ಇಟ್ಕೊಂಡು ತಿರುಗಿಸಿ ಬೈ ಅನ್ ಅಮೌಂಟ್ ಈಕ್ವಲ್ ಟು ಥೀಟಾಕ್ಕೆ ಇನ್ ದ ಕೌಂಟರ್ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್, ಅವಾಗ ಇಲ್ಲಿ ಬರ್ತದೆ. ಸೊ after you perform dk, what happens? xk minus 1 will get merged with, sorry, xk minus 1 and xk will get aligned. I'll repeat once again. How do you define dk? Dk is defined as the translation along zk minus 1 needed to make xk minus 1 intersect with xk. How do you define theta k? Theta k is defined as the rotation about zk minus 1 needed to make xk minus 1 aligned with xk. So after I perform translation, xk minus 1 and xk will get intersect. After I perform rotation, xk minus 1 will get aligned with xk. Note, after performing dk and theta k, both the frames have merged. Earlier ಅಲ್ಲಿ ಏನಾಯ್ತು? ಫಸ್ಟ್ ರೋಟೇಟ್ ಮಾಡಿ ಆಮೇಲೆ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿದ್ವಿ, ಮರ್ಜ್ ಆಯ್ತು. ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ? ಇಲ್ಲಿ ಫಸ್ಟ್ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿ ಆಮೇಲೆ ರೋಟೇಟ್ ಮಾಡಿದ್ವಿ. ಇವನ್ ದೆನ್ ಇಟ್ ಇಸ್ ಮರ್ಜ್. ಆಪರೇಷನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು z axis, ಕರೆಕ್ಟ್ ನಾ? This also corresponds to one screw transformation with respect to the z axis. This is how we define theta k and dk in a common manner. Now I will again explain that theta k. ಒಂದೇ ಡೆಫಿನೇಷನ್ ಈ ಸ್ಲೈಡ್ ಪ್ರೀವಿಯಸ್ ಸ್ಲೈಡ್ ಕಂಬೈನ್ ಮಾಡಿಬಿಟ್ಟು ಒಂದೇ ಡೆಫಿನೇಷನ್ ಕೊಡ್ತೀನಿ ಥೀಟಾಗೆ ಡಿಗೆ. ಹೌ ಡು ಯು ಡಿಫೈನ್ ಥೀಟಾ ಕೆ? ರೊಟೇಷನ್ ಅಬೌಟ್ ಝೆಡ್ ಕೆ ಮೈನಸ್ 1 needed to make xk minus 1 aligned or parallel with xk. How do you define dk? Dk is defined as the translation along zk minus 1 needed to make xk minus 1 intersect with xk or aligned with xk. This is the joint parameters definition. Let me come to the link parameters. Now, how do you define link parameters? They are always defined with respect to the x-axis. How many link parameters are there? There are two link parameters. One is ak, one is alpha k. What is ak? Length of the link k, length of the link k, and the length of our upper arm, length of our lower arm. Upper arm ಅಂದ್ರೆ shoulder in the elbow, lower arm ಅಂದ್ರೆ elbow in the wrist. ಆಮೇಲೆ ಈ ಫಿಂಗರ್ಸ್ಗಳೆಲ್ಲ ಇರ್ತದಲ್ಲ, ಅದಕ್ಕೆ ಲೆಂತ್ ಆಫ್ ದ ಗ್ರಿಪ್ಪರ್ ಅಂತ ಕರೀತಾರೆ, ಲೆಂತ್ ಆಫ್ ದ ಫಿಂಗರ್ಸ್. Now, this is the diagrammatic representation of the link k. What does a link k connect? A link k connect joint jk and jk plus 1. What is the length of the link? The length of the link is given by ak. If this is joint jk and this is jk plus 1, let me take this as a lk. Always it is told that LK is always attached to the end of the link K. The coordinate frames are always attached to the distal end of the links. L0 end of L1 end of link 1, L2 end of link 2, L3 end of link 3, LK end of link K. If this is LK, previous one will be LK minus 1. Then this is JK. What does the joint JK do? Joint JK connects link K and link K minus 1. ಹಿಂದ್ಗಡೆ link K minus 1 ಇದೆ. So ಅದಕ್ಕೆ coordinate frame k minus 1. So there for that joint I am attaching a frame lk minus 1. That axis ಹಿಂಗಿದೆ, z ಹಿಂಗಿದೆ, x ಹಿಂಗಿದೆ, y ಹಿಂಗಿದೆ. To the another joint I'll be attaching x, y, z. That is lk. Lk is giving xk, yk, zk. Now link parameters are always defined with respect to x-axis. Now note that the x-axis of lk minus 1, x-axis of this lk should coincide. Earlier z-axis coincide ಆಗ್ತಿತ್ತು with respect to the joint axis. Here the x of both the frames are coinciding because the link parameters are defined with respect to the x-axis. So this is the diagrammatic representation of the link parameters. ಚೆನ್ನಾಗಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. next slide ಅಲ್ಲಿ explain the definition of alpha k and ak. Now look at this. Where is zk? Zk ಹಿಂಗಿದೆ, ಈ zk ಹಿಂಗಿದೆ. This is the most important one. Now here your most important is zk minus 1. So what is the angle between the zk minus 1 and zk? That is alpha k. Angle between zk minus 1 and zk is nothing but alpha k. ನಾನೀಗ ಇದನ್ನ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡ್ತೀನಿ. ಈ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ವಿಲ್ ಕಮ್ ಇಂಟರ್ಸೆಕ್ಟ್ ವಿತ್ ಝೆಡ್ ಕೆ. ಕರೆಕ್ಟ್ನಾ? ಆಮೇಲೆ ಇದನ್ನ ಹಿಂಗೆ ಡೈರೆಕ್ಟ್ ರೊಟೇಟ್ ಮಾಡ್ತೀನಿ. ಇದನ್ನ ರೊಟೇಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. ಅವಾಗ ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ವಿಲ್ ಬಿ ಪ್ಯಾರಲಲ್ ಟು ಝೆಡ್ ಕೆ. Okay, two methods, either translate and rotate or rotate and translate. Okay, so this is a diagrammatic representation of the link parameters. So the lk is always attached to the end of the link k. Allige one frame attach madu, previous go one frame attach madu. Now you get definition. Look at this. This is a three-dimensional view. Look at this is a link, ಒಂದು ಲಿಂಕ್. ಈ ಲಿಂಕ್ ಕ್ಯಾನ್ ಬಿ, ಇದು ನಮ್ದು ಎಲ್ಬೋ ಇರಬೇಕು, ಇದು ರಿಸ್ಟ್ ಇರ್ಬೋದು, ಅಥವಾ ಇದು ನಮ್ಮ ಶೋಲ್ಡರ್ ಇರ್ಬೋದು, ಇದು ನಮ್ದು ಎಲ್ಬೋ ಇರ್ಬೋದು. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಅಪ್ಪರ್ ಆರ್ಮ್ ಅಂತಾರೆ. ಓಕೆ, ದಟ್ ಈಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ ದ ಶೋಲ್ಡರ್ ಟು ದಿ ಎಲ್ಬೋ. So to the shoulder we are attaching one frame, to the elbow we are attaching one frame. Okay, so the x-axis of that frame and the previous frame should be aligned in the same line. Okay, the angle between the z-axis is called as the link twist angle. I'll repeat it. If this is zk minus 1, if this is zk, ಎರಡು perpendicular ಆಗಿದೆಯಲ್ಲ, so that angle is called as a link twist. ಯಾವಾಗ perpendicular ಆಗಿರುತ್ತೆ ಹೇಳಿ? See, the two joint axes can be parallel or the two joint axes can be perpendicular. ನಾನು ತೋರಿಸ್ನಲ್ಲ, ಎರಡು ಫ್ಯಾನು ಪಕ್ಕ ಸೀಲಿಂಗ್ ಫ್ಯಾನ್ ಇರುತ್ತೆ. ಸೊ ದ ಜಾಯಿಂಟ್ ಆಕ್ಸಿಸ್ ಇಸ್ ಪ್ಯಾರಲಲ್, ಆಲ್ಫಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ಇನ್ನೊಂದು ಸೀಲಿಂಗ್ ಫ್ಯಾನ್ ಇರುತ್ತೆ, ಟೇಬಲ್ ಫ್ಯಾನ್ ಇರುತ್ತೆ, ಸೊ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ದಿಸ್ ಈಸ್ ದಟ್ ಕೇಸ್. Okay, so this distance is called as the length of the link k, which is denoted by ak. Got it? So this is xk, this is xk, and this is zk, this is zk minus 1. Now you get define ಮಾಡಬೇಕು. Remember, look at this. Link parameters are always defined with respect to the x-axis. So there are two parameters. One is the link twist angle alpha k, and there is the link angle, link length ak. How do you define link twist angle alpha k? It is the rotation about xk needed to make zk minus 1 parallel or aligned with zk. Two ವಿಧ ಡಿಫೈನ್ ಮಾಡಬಹುದು, ಒಂದು ಪ್ಯಾರಲಲ್, ಒಂದು ಅಲೈನ್ಡ್. Or the angle from zk minus 1 to zk is called as link twist angle, or the angle between the two joint axes to which the link k is connected. Remember, the two joint axes can be parallel or the two joint axes can be perpendicular. Okay, that already I explained. ಎರಡು ಟೇಬಲ್ ಫ್ಯಾನು, ಒಂದು ಸೀಲಿಂಗ್ ಫ್ಯಾನು. ಆರ್ ಮಿನಿ ಡ್ರಾಫ್ಟರ್ ತಗೊಳ್ಳಿ. ಮಿನಿ ಡ್ರಾಫ್ಟರ್ ತಗೊಂಡ್ರೆ 3 ಜಾಯಿಂಟ್ಸ್ ಇರುತ್ತಾ, ಎಲ್ಲ ಜಾಯಿಂಟ್ಸ್ ಪ್ಯಾರಲಲ್ ಆಗಿರುತ್ತೆ. ಆಲ್ಫಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ದಟ್ ಈಸ್ ಲಿಂಕ್ ಟ್ವಿಸ್ಟ್ ಆಂಗಲ್. ಲಿಂಕ್ ಟ್ವಿಸ್ಟ್ ಆಂಗಲ್ ಅಂದ್ರೆ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ದ ಝೆಡ್ ಆಕ್ಸಸ್. ಓಕೆ, ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ದ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇಸ್ ಥೀಟಾ. ಜಾಯಿಂಟ್ ಅಲ್ಲಿ angle between the x-axis is theta, angle between the z-axis is alpha. That gives the link twist angle. How do you define link twist angle? Link twist angle is defined as the rotation about xk needed to make zk minus 1 parallel or aligned with zk, or the link length ak. How do you define link length ak? It is the length of the link k, or the shortest distance between zk minus 1 and zk, or the common perpendicular between the two joint axes. The common perpendicular between the two joint axes is called as zk. ನೋಡಿ, zk minus 1 ಹಿಂಗಿತ್ತು ಅಲ್ವಾ, ಈ zk ಉದ್ದಕ್ಕೆ ಮೇಲಕ್ಕಿತ್ತು. So what is the common perpendicular? That is called as ak. Or the shortest distance or the common perpendicular is both one and the same. Now how do you define link length? It is defined as the translation along xk needed to make zk minus 1 intersect or aligned with zk, defined in two ways, either intersect or align. So these are the empirical formulas, the theorems, which has to be very, very important. Mark it up. Okay, ಇನ್ನೊಂದ್ಸರಿ ನೆನ್ಪು ಮಾಡ್ಕೊಳ್ಳಿ, ನಾನು ಅಲ್ಲಿ ಡಯಾಗ್ರಾಮೆಟಿಕ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೇನೆ. ಸೊ ಆಲ್ಫಾ ಕೆ ಅಂದ್ರೆ ರೊಟೇಷನ್ ಅಬೌಟ್ ಎಕ್ಸ್ ಕೆ ನೀಡೆಡ್ ಟು ಮೇಕ್ ಝೆಡ್ ಕೆ ಮೈನಸ್ 1 ಪ್ಯಾರಲಲ್ ಆರ್ ಅಲೈನ್ಡ್ ವಿತ್ ಝೆಡ್ ಕೆ. ಲಿಂಕ್ ಲೆಂತ್ ಟ್ರಾನ್ಸ್ಲೇಷನ್, ಆಲ್ಫಾ ಯಾವಾಗಲೂ ರೊಟೇಷನ್, ಲೆಂತ್ ಯಾವಾಗಲೂ ಟ್ರಾನ್ಸ್ಲೇಷನ್. ಟ್ರಾನ್ಸ್ಲೇಷನ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಕೆ ನೀಡೆಡ್ ಟು ಮೇಕ್ ಝೆಡ್ ಕೆ ಮೈನಸ್ 1 intersect or aligned with zk. Now look at this. Will come here. Now this is the diagrammatic representation of the link parameters. Now illu first translate ಮಾಡ್ತೀನಿ, ಆಮೇಲೆ rotate ಮಾಡ್ತೀನಿ. ಇನ್ನೊಂದು ಸರಿ first rotate ಮಾಡ್ತೀನಿ, translate ಮಾಡ್ತೀನಿ. ಹೆಂಗಿದ್ರು ಕೊನೆಗೆ frames merge ಆಗ್ತದೆ. Okay, now look at this. ನಾನೀಗ ಈ ಫ್ರೇಮ್ ನ I will translate by an amount equal to this distance. ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಈ ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಬಂದು ಇಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗುತ್ತೆ, ಈ ವೈ ಕೆ ಮೈನಸ್ ಒನ್ ಇಲ್ಲಿ ಬರುತ್ತೆ, ಈ ಎಕ್ಸ್ ಕೆ ಮೈನಸ್ ಒನ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಗೊತ್ತಾಯ್ತಲ್ಲ? ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಲೆಂತ್ ಆಫ್ ಲಿಂಕ್ ಕೆ. ಫಸ್ಟ್ ಟ್ರಾನ್ಸ್ಲೇಷನ್ ಮಾಡ್ತೀನಿ, ಅನಂತರ ರೊಟೇಷನ್ ಮಾಡ್ತೀನಿ. ಸೊ ಹೌ ಡು ಯು ಡಿಫೈನ್ ಎ ಕೆ? ಎ ಕೆ as defined as the translation along xk, the translation along xk needed to make zk minus 1 intersect with zk. Okay, how do you define AK? The translation along xk needed to make zk minus 1 intersect with zk is called as AK. That is a translational operation along which axis? X axis, F1. So it is represented by a fundamental homogeneous coordinate translation matrix along the X axis. Now I will rotate by an amount equal to alpha k with respect to the X axis. Okay, so after you perform trans of AK, after I perform AK, what happens? ZK minus 1 intersected with ZK. Now I'll perform alpha K. How do you define alpha K? Alpha K is defined as the rotation about XK needed to make ZK minus 1 aligned with ZK. ಈಗ ಇಟ್ಕೊಂಡು ಈ ವೆಕ್ಟರ್ ಇದೆಯಲ್ಲ ಇದ್ರಲ್ಲಿ ಇಟ್ಕೊಂಡು ಕ್ಲಾಕ್ ವೈಸ್ ಇದು ರೊಟೇಟ್ ಮಾಡಿ ಹಿಂಗೆ ಬೈ ಅನ್ ಅಮೌಂಟ್ ಈಕ್ವಲ್ ಟು ಆಲ್ಫಾಗೆ ತಿರುಗಿಸಿದಾಗ ಏನಾಗುತ್ತೆ, ಹಿಂಗೆ ಈ ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಮೇಲಕ್ಕೆ ಹೋಗುತ್ತೆ, ಈ ವೈ ಕೆ ಮೈನಸ್ ಒನ್ ಹಿಂದಕ್ಕೆ ಬರುತ್ತೆ. ಕರೆಕ್ಟ್ ತಾನೆ? ದಟ್ ಈಸ್ ವಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಆಲ್ಫಾ ಕೆ. ಸೊ ಹೌ ಡು ಯು ಡಿಫೈನ್ ಆಲ್ಫಾ ಕೆ? ಆಲ್ಫಾ ಕೆ ಇಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ ದ ರೊಟೇಷನ್ ಅಬೌಟ್ ಎಕ್ಸ್ ಕೆ needed to make zk minus 1 aligned with zk. Zk minus 1 aligned with zk. So after you perform alpha k, what happens? Zk minus 1 and zk will become aligned. Now after you perform ak and alpha k, first ak ಮಾಡಿದ್ವಿ, ಆಮೇಲೆ alpha k ಮಾಡಿದ್ವಿ, ಏನಾಯ್ತು? ಎರಡು ಫ್ರೇಮು ಮರ್ಜ್ ಆಯ್ತು. lk and lk minus 1 merged because it is a translation with respect to the x axis. I'll again define what is ak. AK is defined as the translation along x-axis needed to make zk minus 1 intersect with zk. How do you define alpha k? Alpha k is defined as the rotation about x-axis needed to make zk minus 1 aligned with zk. By how much amount? If you rotate, this zk minus 1 and zk will get aligned by an amount equal to alpha k. That is called as the alpha k. So after I perform AK and alpha k, the two frames have merged. ನಾವೀಗ ಫಸ್ಟ್ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿ ಆಮೇಲೆ ರೊಟೇಟ್ ಮಾಡಿದೆ, ನನಗೆ ಉಲ್ಟಾ ಮಾಡ್ತೀನಿ. ಐ ವಿಲ್ ಫಸ್ಟ್ ರೊಟೇಟ್ ಮಾಡಿಬಿಟ್ಟು ಆಮೇಲೆ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡ್ತೀನಿ. ಸಿ ದಿಸ್ ಇಸ್ ದ ಡಯಾಗ್ರಾಮ್ಯಾಟಿಕ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಫಾರ್ ದ ಲಿಂಕ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್. ಕರೆಕ್ಟ್ನಲ್ಲ? ದಿಸ್ ಇಸ್ ದ ಲೆಂತ್ ಎ ಕೆ. ನಾವು ಫಸ್ಟೇ ರೊಟೇಟ್ ಮಾಡಿಬಿಡಿ. ನಾವು ಐ ರೊಟೇಟ್ ದಿಸ್ ಫ್ರೇಮ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಬೈ ಅನ್ ಅಮೌಂಟ್ ಆಲ್ಫಾಗೆ. ಹಿಂಗೆ ರೊಟೇಟ್ ಮಾಡ್ತೀನಪ್ಪ ನಾನು. ರೊಟೇಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಈ ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ, ವೈ ಕೆ ಮೈನಸ್ ಒನ್ ಇಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ, ಎಕ್ಸ್ ಕೆ ಮೈನಸ್ ಒನ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. ಅಂದ್ರೆ ಈ ಎಕ್ಸ್ ಇದನ್ನ ಇಟ್ಕೊಂಡು ಹಿಂಗೆ ಗುಮಾಯಿಸ್ಬೇಕು, ಇದು ತಿರುಗಿಸ್ಬೇಕು. So how do you define alpha k? Alpha k is defined as the rotation about xk needed to make zk minus 1 parallel with zk. After I perform alpha k, what happened? Zk minus 1 and zk ಎರಡು ಪ್ಯಾರಲ್ ಆಯಿತು. ನಾನೀಗ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡ್ತೀನಿ, ಹಿಂಗಾಯ್ತಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಐ ವಿಲ್ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಬೈ ಅನ್ ಅಮೌಂಟ್ ಈಕ್ವಲ್ ಟು ಎ ಕೆ. Okay, now how do you define AK? AK is defined as the translation along xk needed to make zk minus 1 aligned with zk. AK is defined as the translation along xk needed to make zk minus 1 aligned with zk. So after I perform AK, the length of the link k, what happened? Zk and zk minus 1 ಎರಡು merge ಆಯಿತು. Now after I perform alpha k and AK, ಒಂದಾದ್ಮೇಲೆ ಒಂದು ಮಾಡಿದೆ, ಫಸ್ಟ್ ರೊಟೇಷನ್ ಮಾಡಿದೆ, ಆಮೇಲೆ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿದೆ, ಏನಾಯ್ತು? ಎರಡು ಫ್ರೇಮ್ ಮರ್ಜ್ ಆಗೋಯ್ತು. ಸೊ ದಿಸ್ ಈಸ್ ವಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದ ಲಿಂಕ್ ಟ್ವಿಸ್ಟ್ ಆಂಗಲ್ ಅಂಡ್ ದ ಲಿಂಕ್ ಲೆಂತ್. ಅಗೇನ್ ಐ ಡಿಫೈನ್ ಒನ್ ಸಿಂಗಲ್ ಡೆಫಿನಿಷನ್, ಎರಡು ಸ್ಲೈಡ್ ಇದ್ದು. How do you define alpha k? Alpha k is defined as the rotation about xk needed to make zk minus 1 parallel or intersect with zk. The earlier slide. How do you define AK? AK is defined as the translation along xk needed to make zk minus 1 intersect with zk or aligned with, sorry, parallel with aligned with zk. ಎರಡು ಡೆಫಿನಿಷನ್ ಕಂಬೈನ್ ಮಾಡಿ ಒಂದೇ ಇದು ಮಾಡಿದ್ದೀನಿ. ಓಕೆ, now look at this. Here first ಏನಾಯ್ತು? ನಾನು ಇಲ್ಲಿ ರೊಟೇಟ್ ಮಾಡಿದೆ. ಡಿಫಿನಿಷನ್ ಆಫ್ ಅಬೌಟ್ ಥೀಟಾ ಕೆ. ಹೌ ಡು ಯು ಡಿಫೈನ್ ಥೀಟಾ ಕೆ? ರೊಟೇಷನ್ ಅಬೌಟ್ ಝೆಡ್ ಕೆ ಮೈನಸ್ 1 needed to make xk minus 1 aligned with xk. Now dk, translation along zk minus 1 needed to make zk minus 1 needed to make xk minus 1 aligned with xk. So after I perform theta k and dk, the two frames have merged. Now link parameters. ಓಕೆ ನಾವು ಫಸ್ಟೇ ನಾನು ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿಬಿಡ್ತೀನಿ. ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿದ್ರೆ ಏನಾಯಿತು, ಈ ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಮತ್ತು ಝೆಡ್ ಕೆ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗೋಯ್ತು. ಸೊ ಐ ಡಿಫೈನ್ ಎ ಕೆ ಆಸ್ ದ ಟ್ರಾನ್ಸ್ಲೇಷನ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಕೆ ನೀಡೆಡ್ ಟು ಮೇಕ್ ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಇಂಟರ್ಸೆಕ್ಟ್ ವಿತ್ ಝೆಡ್ ಕೆ. ನಾವು ಈಗ ತಿರುಗಿಸಿ ಹಿಂಗೆ ಆಲ್ಫಾ ಕೆ ಅಲ್ಲಿ. ಸೊ ಆಲ್ಫಾ ಕೆ ಇಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ ದ ರೊಟೇಷನ್ ಅಬೌಟ್ ಎಕ್ಸ್ ಕೆ ನೀಡೆಡ್ ಟು ಮೇಕ್ ದಿಸ್ ಝೆಡ್ ಕೆ ಮೈನಸ್ ಒನ್ ಅಲೈನ್ಡ್ ವಿತ್ ಝೆಡ್ ಕೆ. So now this is the diagram which shows the two frames LK and LK minus 1 coincides after performing joint parameters and link parameters. Now once I perform joint parameter operation, ಎರಡು frames merge ಆಯಿತು. Once I perform link parameter operation, again the two frames will merge. One time with respect to the z axis, another time with respect to the x axis. So this is the definition of dk, theta k, ak, alpha k. ಈ ನಾಲ್ಕಕ್ಕೂ ಕೈನಮ್ಯಾಟಿಕ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಅಂತ ಕರೀತಾರೆ, which is split up into joint and link. Joint parameters and link parameters. Joint parameters are dk, theta k, then link parameters ak, alpha k, because a robot is made up of links and joint. Note, for every joint there are 4 kinematic parameters. For n joints there are 4 n kinematic parameters. First slide ಅಲ್ಲಿ ತೋರಿಸಿದ್ನಲ್ಲ 6 joints ಇತ್ತು, so 6 into 4 24 kinematic parameters ಆ ತರ. So these 4 n kinematic parameters constitute the minimal set needed for specifying the kinematic configuration of any robot arm. For every joint there are 4 kinematic parameters, out of which only one kinematic parameter is variable, remaining 3 are fixed constant. So theta is variable for a rotary joint, whereas d is variable for a prismatic joint. Remaining 3 kinematic parameters are fixed. ಯಾಕೆಂದ್ರೆ length of the link is constant ಅಲ್ವಾ. ಈಗ for example, if I take the human bone, the upper arm, shoulder ಮತ್ತೆ elbow, that bone is fixed na, the length is fixed, so link length is fixed. Axis ಅದು ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಜಾಯಿಂಟ್ ಅದು ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. So for any given joint, there are 4 kinematic parameters, out of which only one is variable, remaining 3 are fixed because they are constant. They are specified by the manufacturer. Or once a robot comes out of the industry, or once a human being is being born, the physical dimensions will be fixed. So the physical dimensions are related to alpha, a and d. Okay, that's one thing you remember. For each joint there are 4 kinematic parameters, out of which only one kinematic parameter is variable. The remaining 3 kps are fixed, which is that only one is variable. Theta is variable for a rotary joint, d is variable for a prismatic joint. Now the last part is general link coordinate transformation matrix ಅಂತ ಬರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಟಿ ಕೆ ಟು ಕೆ ಮೈನಸ್, ತಪ್ಪು ಬರೆದಿದೆ, ಇಟ್ ಶುಡ್ ಬಿ ಟಿ ಊಪರ್ ಕೆ ಇರಬೇಕು, ಕೆಳಗಡೆ ಕೆ ಮೈನಸ್ ಒನ್ ಇರಬೇಕು. ಸೊ ಸೂಪರ್ ಸ್ಕ್ರಿಪ್ಟ್ ಕೆ, ಕೆಳಗಡೆ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್. ಸೊ ಜನರಲ್ ಲಿಂಕ್ ಕೋಆರ್ಡಿನೇಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನೋಡಿ, ಜಿ ಎಲ್ ಸಿ ಟಿ ಎಂ. ನೀವು ಎಷ್ಟು ಟೈಪ್ ಆಫ್ ಮೆಟ್ರಿಕ್ಸ್ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ? ಯು ಸ್ಟಡಿಡ್ ಎ coordinate transformation matrix, R rotation matrix, ROT rotation matrix, then translation matrix, CRM composite rotation matrix, then screw transformation matrix. This is also one general matrix which is the heart of the robotics. GLCTM and general link coordinate transformation matrix. How do you define? It is defined as a matrix which transforms the link coordinates from one frame to another frame. Nodi, it is a matrix which transforms the link coordinates from one frame to the another frame. It's a matrix which transforms the homogeneous coordinates from frame k to frame k minus 1. So transform the homogeneous coordinates of q from frame k to k minus 1, 4 operations are needed. So if I ಏನ್ ಮಾಡ್ತಾ ಇದೆ ಈ matrix ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡ್ತಿದೆ, ಏನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡ್ತಾ ಇದೆ? homogeneous coordinates ನ ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ? ಫ್ರೇಮ್ ಕೆ ಇಂದ ಫ್ರೇಮ್ ಕೆ ಮೈನಸ್ 1, ಅಂದ್ರೆ ಮೇಲಿಂದ ಕೆಳಗೆ, ಮೊಬೈಲ್ ಇಂದ ಫಿಕ್ಸ್ಡ್ ಗೆ. ಗೊತ್ತಾಯ್ತಲ್ಲ? ಸೊ ಟು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ದ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಫ್ರಮ್ ಒನ್ ಫ್ರೇಮ್ ಟು ಅನದರ್ ಫ್ರೇಮ್, 4 operations are needed. Which are those 4 operations? Theta, d, a and alpha. Why 4 operations are needed? Because one joint is associated with 4 kinematic parameters. Therefore, in order to transform the coordinates from one frame to another frame, 4 steps or 4 operations are required. That means we have to merge the two frames LK and LK minus twice. Once with respect to x-axis, the link parameters, another time with respect to the z-axis, that is the joint parameters. Okay, I'll repeat it once again, because this forms the base for the direct kinematics and the inverse kinematics. What is a general link coordinate transformation matrix? It is a matrix which transforms the homogeneous coordinates from one frame to another frame, from frame k to frame k minus 1. So in order to transform the homogeneous coordinates from one frame to another frame, four steps are needed. Which are those four steps? Theta, d, a, and alpha. Why four steps are needed? Because one joint is associated with four kinematic parameters. Therefore, in order to transform the frame k coordinates into frame k minus 1 coordinates, we have to perform four operations or four steps. That means it is equivalent to merging the two frames twice. Once with respect to the link parameters, another time with respect to the joint. Look at this. This is the diagrammatic representation of the general link coordinate transformation matrix. ಇದು ಲಿಂಕ್ ಕೆ ಇರುತ್ತೆ. ಇದು ಎಂಡ್ ಆಫ್ ದ ಲಿಂಕ್ ಕೆಗೆ ಯಾವ ಫ್ರೇಮ್ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೀರಾ? ಎಲ್ ಕೆ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೀರಾ. ಇದು ಎಲ್ ಕೆ ಆದರೆ ಇದು ಎಲ್ ಕೆ ಮೈನಸ್ ಒನ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಇದೆ, ಕ್ಯೂ ಕೆ ಅಂತ ಇದೆ ಇಟ್ಕೊಳ್ಳಿ. ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಆಫ್ ದ ಪಾಯಿಂಟ್ ಕ್ಯೂ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಕೇತ್ ಕೋಆರ್ಡಿನೇಟ್ ಫ್ರೇಮ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ 10, 20, 30. Okay, I want to find what is its equivalent value in this frame. So ಏನ್ ಮಾಡ್ಬೇಕು ಅವಾಗ? You have to map the coordinates or transform the coordinates from year to year. Understood? I'll explain once again. This is a diagrammatic representation of the link coordinate, general link coordinate transformation matrix. ಇದು ಫಾರ್ಮುಲಾ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ನೀವು ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಮಾಡಿದ್ರಿ ನೋಡಿ, q to the power of f is equal to a matrix, direct matrix into q to the power of m. ಮೇಲಿಂದ ಕೆಳಗೆ ಬರಬೇಕು ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಕೆಳಗಿಂದ ಮೇಲಕ್ಕೆ ಹೋಗ್ಬೇಕಂದ್ರೆ ಇನ್ವರ್ಸ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ವಾಟ್ ಈಸ್ ದಿಸ್ ಎಲ್ ಕೆ? ಇಟ್ ಈಸ್ ಅ ಫ್ರೇಮ್ ವಿಚ್ is attached to the end of the link k. LK is having axis xk, yk, zk. ಇದು LK ಆದ್ರೆ previous one LK minus 1. LK minus 1 will be having axis xk minus 1, yk minus 1, zk minus 1. Now I'll take a point. This point is with respect to this frame. Say qk. What is qk? Coordinates of the point q with respect to the kth coordinate frame. Say it is having 10, 20 and 30. I want to find what is its equivalent value in this frame. So ಏನ್ ಮಾಡಬೇಕು? ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡಬೇಕು, ಮ್ಯಾಪ್ ಮಾಡಬೇಕು. Transform the coordinates from where to where? From one frame to another frame. That is done by making use of a matrix called as GLCTM. What is that GLCTM? It's a matrix which transforms the coordinates from one frame to another frame. General link coordinate transformation matrix. A matrix which transforms the coordinates from one frame to another frame. Which is that one frame? From the kth frame to the k minus 1 frame. Kth frame to the k minus 1 frame. Superscript always starting ಅಲ್ಲಿ ಇರುತ್ತೆ, ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಯಾವಾಗಲೂ ಕೆಳಗಡೆ ಇರ್ತದೆ. ಓಕೆ, ಸೊ ಈ ಫಾರ್ಮುಲಾ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಸೊ ನಾವು ದಟ್ ಜನರಲ್ ಲಿಂಕ್ ಕೋಆರ್ಡಿನೇಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅದು ಡೀಟೇಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಐ ಟೋಲ್ಡ್ ಯು ನಾ, ಇಫ್ ಐ ವಾಂಟ್ ಟು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ದ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಫ್ರಮ್ ಒನ್ ಫ್ರೇಮ್ ಟು ಅನದರ್ ಫ್ರೇಮ್, ಇಟ್ ಇಸ್ ಈಕ್ವಲೆಂಟ್ ಟು ಮರ್ಜಿಂಗ್ ದೀಸ್ ಟೂ ಫ್ರೇಮ್ಸ್ ಟ್ವೈಸ್. Once with respect to the x-axis, once with respect to the z-axis. So that is equivalent to performing four operations: theta, d, a, and alpha. Okay, look at this. Now this four operations explain ಮಾಡ್ತಾ ಇದೀನಿ. So what is theta k? Rotation about zk minus 1. So what is the effect of operation 1? The effect of operation 1 is to make xk minus 1 parallel with xk. Correct na? So how do you define theta k, zk? Sorry, theta k. Theta k is defined as the rotation about z axis needed to make xk minus 1 parallel with xk. After I perform theta k, ಇವೆರಡು x axis parallel ಆಗ್ಬಿಡ್ತದೆ. Then dk. dk ಅಲ್ಲಿ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? This is zk minus 1 and xk minus 1 and xk will get aligned. So one time merge ಆಯ್ತು. So operation number 2 is dk. That is a translation along zk minus 1. What is the operation effect of operation number 2? The effect of operation number 2 is to make xk minus 1 aligned with xk. So this is equal to a translational operation along the z axis. So one time merge ಆಯ್ತು. Then you take ak. How do you define ak? It is a link length. Translation along xk. How do you define it? Effect of operation 3 is to make zk minus 1 intersect with zk. Okay, what is the effect of operation 4? Is to get aligned. Zk minus 1 aligned with zk. Okay, once with respect to the link parameters. So now one time merge ಆಯ್ತು, another time merge ಆಯ್ತು. This is one screw transformation along z axis. This is one screw transformation along x axis. Look at this. So joint parameters, the effect of operation 1 and 2 after performing theta k dk or dk theta k, the two coordinate frames merges. So operation 1 and 2 forms a screw transformation matrix along the z axis. Okay, screw transformations ali rotations and translations are matrix commutative. Theta into rota is equal, rot is equal to trans into rot is equal to rot into trans. Then effect of link parameter operation, effect of operation number 3 and operation number 4. So after you perform AK and alpha k, or alpha k and AK, the two coordinate frames will merge. Okay, so this corresponds to one screw transformation matrix along the x-axis. Now look at this. This is the same thing. Now, one cell merge ಆಯ್ತಾ ಜಾಯಿಂಟ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಅಲ್ಲಿ, one cell merge ಆಯ್ತಾ ಲಿಂಕ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಅಲ್ಲಿ. So if I want to transform the coordinates from one frame to another frame, it's equivalent to merging the frames twice, once with respect to joint parameters, another with respect to the link parameters. Okay, now that general link coordinate transformation matrix is a function of theta k, dk, ak, alpha k. That is a combination of two screw transformation, rotation and translation along z axis, rotation and translation along the x axis. Screw theta and d can be written as rot into trans. Screw a and alpha can be written as trans into rot. Trans of ak comma 1, rot of alpha k comma 1. Fundamental homogeneous rotation, fundamental homogeneous translation. This is the rotation along z axis, so ಮೇಲ್ಗಡೆ theta ಬರುತ್ತೆ, ಇಲ್ಲಿ 1 ಬರುತ್ತೆ. This is the translation along z axis by an amount equal to dk, so z axis projection ಬರುತ್ತೆ. This is the translation along x axis, so x axis ಇಲ್ಲಿ ಬರ್ತದೆ ak. This orientation same ಇರುತ್ತೆ, so identity matrix. Rot of alpha k comma 1, rotation is with respect to x axis, so cos theta alpha theta ಇಲ್ಲಿ ಬರ್ತದೆ. ಇವು ನಾಲ್ಕನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ, ನಾಲ್ಕು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರ್ತದೆ. ಸೊ ದಿಸ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್, ದಿಸ್ ಈಸ್ ದ ಜನರಲ್ ಲಿಂಕ್ coordinate transformation matrix. It is a matrix which transforms the coordinates from one frame to the another frame, that is frame k to k minus 1. So here k takes the value from 1 to n. N coincides with the degree of freedom or the number of axes. Now here what is that equation? Qk minus 1 is equal to tk to k minus 1 into qk. If I want to transform the coordinates from kth frame to k minus 1 frame, make use of this GLCTM. How do you define this GLCTM? It's a matrix which transforms the coordinates from frame k to k minus 1. What is qk? Homogeneous coordinates of the point q with respect to the kth frame. Okay, what is qk minus 1? Homogeneous coordinates of the point q with respect to the k minus 1th frame. So in order to transform the coordinates from top to bottom, make use of this GLCTM, general link coordinate transformation matrix. It is a matrix which transforms the homogeneous coordinates from frame k to k minus 1. Okay, now you go on giving values for k. This is that matrix. Mug it up, very very important. Tk to k minus 1. What is the tk to k minus 1? It's a matrix which transforms the homogeneous coordinates from frame k to k minus 1. So to map the coordinates from one frame to another frame, that is from the mobile to the fixed, ಮೇಲಿಂದ ಕೆಳಗೆ ಬರಕ್ಕೆ. So what is the use of this GLCTM? The use of this GLCTM is to find out the position and orientation of the robot arm with respect to the base. That is, how does it give you the final position and it is used to find out give the final position and orientation of the arm with respect to the base. Once you know the final position and orientation of the arm with respect to the base, that is given as input to the robot goes and stops at that particular point. ಅದು ಹೋಗಿ ಕಪ್ ತಗೊಳ್ತದೆ ಅಥವಾ ಆಬ್ಜೆಕ್ಟ್ ಹಿಡಿತದೆ, like that. How you pick up? See, you are doing natural intelligence. ಮಷೀನ್ಗೆ ಏನು ಅರ್ಥ ಆಗೋದಿಲ್ಲ. You have to give in ಇನ್ಫಾರ್ಮೇಶನ್, ಅದು ಕೊಡಬೇಕು ಇನ್ಫಾರ್ಮೇಶನ್. ನೀನು ತೀಟಾ ಮೂವ್ ಮಾಡು, ನೀನು 90 ಡಿಗ್ರೀಸ್ ಮೂವ್ ಮಾಡು, ನೀನು 10 ಸೆಂಟಿಮೀಟರ್ಸ್ ಮೂವ್ ಮಾಡು. ಹೌ ಯು ಆರ್ ಗಿವಿಂಗ್ ದಿಸ್? ಆಲ್ ದಿಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಎ ತ್ರೀ ಡೈಮೆನ್ಷನಲ್ ಮೆಟ್ರೈಸಸ್, ವಿಚ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಕೈನಮ್ಯಾಟಿಕ್ ಅನಾಲಿಸಿಸ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, how do you define general link coordinate transformation matrix? It's a matrix which transforms the homogeneous coordinates from the frame k to the k minus 1. What is the use? The use is to map the coordinates from one frame to another frame. One frame and ಮೇಲಿಂದ ಕೆಳಗೆ. General and the k to k minus 1. ಈಗ k is equal to 6 ಹಾಕದ್ನಪ್ಪ, 6 to 5 ಆಗುತ್ತೆ. 5 ಹಾಕಿದೆ, 5 to 4, 4 ಹಾಕಿದೆ, 4 to 3, 3 ಹಾಕಿದ್ರೆ 3 to 2, 2 ಹಾಕಿದ್ರೆ 2 to 1, 1 ಹಾಕಿದ್ರೆ ಇದು 1, ಇದು 0 ಆಗುತ್ತೆ. Okay, so to map the coordinates from one frame to another, make use of this matrix. I told na, 6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1, 1 to 0. To find the position and orientation of the arm with respect to the base. Once you know the position and orientation of the arm with respect to the base, mathematically you calculate ಮಾಡಿದ್ರೆ, and that is given as input to the robot goes and stops at that particular point. Mug it up. Now I want to find out t1 to 0. ಏನ್ ಮಾಡಬೇಕು? ಆ k to k minus 1 ನಲ್ಲಿ k is equal to 1 ಹಾಕಿ. k is equal to 1 ಹಾಕಿದ್ರೆ ಮೇಲ್ಗಡೆ 1 ಆಗುತ್ತೆ, ಕೆಳಗಡೆ 1 minus 1 0 ಆಗುತ್ತೆ. So that t1 to 0 is a function of theta 1 d1 a1 alpha 1. Put k is equal to 1 and theta 1 d1 a1 alpha 1 in this matrix. I am going to get t1 to 0. What does the t1 to 0 do? It will map the coordinates from the frame 1 to the frame 0. Map ಮಾಡ್ತದೆ ಮೇಲ್ಗಡೆಯಿಂದ ಕೆಳಗಡೆದಕ್ಕೆ. So that gives the this t1 to 0 gives you the position and orientation of the shoulder with respect to the base. You take this is the base, so this is the shoulder. So for the base, which frame you're attaching? L0. For the shoulder, which frame you're attaching? L1. So if I want to map the L1 coordinates to L0 coordinates, make use of this GLCTM t1 to 0 by putting k is equal to 1. So if I put k is equal to 1, what happens? This becomes t1 to 0. What does t1 to 0 do? T1 to 0 maps the frame 1 coordinates into frame 0 coordinates. So that is a function of theta 1 d1 a1 alpha 1. Okay. Similarly, put k is equal to 2 3 4 5 and compute the other matrices. Okay. So what does t1 to 0 do? It maps the frame 1 coordinates into frame 0 coordinates. ಅಂದ್ರೆ ಮ್ಯಾಪ್ ಮಾಡಿದ್ರೆ ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನಿಮಗೆ ಗೊತ್ತಾಯ್ತಪ್ಪ, ಈ ನ್ಯೂಮೆರಿಕಲ್ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಯ್ತು. ಇದನ್ನ ಕಂಪ್ಯೂಟರ್ಗೆ ಫೀಡ್ ಮಾಡಿ, ಕಂಪ್ಯೂಟರ್ is connected to the robot goes and stops at that particular shoulder point. So, okay, this t1 to 0 gives the position and orientation of the shoulder with respect to the base and is a function of 4 kinematic parameters: d1, theta 1, a1, because every joint is associated with 4 kps. So how does it give the orientation and position? The first 3 columns ಇರುತ್ತಲ್ಲ, the first 3 columns gives you the orientation. Okay, ಈ ಫಿಂಗರು ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ಪಾಯಿಂಟ್ ಮಾಡಬೇಕು, that is the orientation. Okay, the last column gives you the position of the shoulder with respect to the base. The first 3 columns gives you the orientation, the last column gives you the position with respect to the base. If this matrix has given as input to the robot shoulder goes and stops at that particular point. ಗೊತ್ತಾಯ್ತಲ್ಲ? So this is what is called as GLCTM, General Link Coordinate Transformation Matrix. A matrix which transforms the coordinates from one frame to the another frame. Like that, ನಾನು 2 ಹಾಕಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ? ಇದು 2 to 1 ಆಗುತ್ತೆ. 3 ಹಾಕಿದ್ರೆ 3 to 2 ಆಗುತ್ತೆ. 4 ಹಾಕಿದ್ರೆ 4 to 3 ಆಗುತ್ತೆ. 5 ಹಾಕಿದ್ರೆ 5 to 4 ಆಗುತ್ತೆ. Like that. Okay, so general link coordinate transformation matrix and matrix which transforms the coordinates from one frame to the another frame. That is why it is called as a general. Go on giving values for k. What is the function of that matrix? It gives you the orientation and the position. First 3 columns orientation, last column gives the position. Orientation is given by a 3 by 3 matrix, position is given by a positional vector. So this much you should remember for the some basic points. So idರಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ? First we explained how to attach the different coordinate frames to the respective joints of the robot arm. So for a n-axis robot, there are n axis, then n joints, then n plus 1 3D coordinates, n plus 1 frames, out of which one frame is attached to the base, fixed, remaining all are attached to the movable points. Okay, out of which the last frame attached ಮಾಡ್ತೀರಾ ln, it is attached according to some rule. What is it according to some rule? Z axis of the last frame will be pointing in the direction which the finger is pointing. ಓಕೆ, ಈಗ ಕೈ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಕಪ್ ಹಿಡಿಯಕ್ಕೆ ಅಂತ, ಆ ಡೈರೆಕ್ಷನ್ Z ಆಕ್ಸಿಸ್ ಹಾಕ್ಬೇಕು. ಓಕೆ, ಆಮೇಲೆ ವೈ ಆಕ್ಸಿಸ್ ಹೆಂಗ್ ಹಾಕ್ತೀರಾ? ಫಿಂಗರು ಓಪನ್ ಕ್ಲೋಸ್ ಆಗುತ್ತೆ, ಆ ಡೈರೆಕ್ಷನ್ ವೈ ಆಕ್ಸಿಸ್ ಹಾಕ್ಬೇಕು. ಯಾಕಂದ್ರೆ ಸ್ಲೈಡಿಂಗ್ ವೆಕ್ಟರ್ ಅಂತ ಕರೀತಾರೆ. ಇಟ್ ಸ್ಲೈಡ್ಸ್ ಇನ್ ಆರ್ ಸ್ಲೈಡ್ ಔಟ್. ನಾರ್ಮಲ್ ಟು ದಿಸ್ ಯು ಅಟ್ಯಾಚ್ ದಿ ನಾರ್ಮಲ್ ವೆಕ್ಟರ್ xn. So this is how you attach the last coordinate frame. Then important points are important topic is the kinematic parameters. How did you define kinematic parameters? They are the parameters which are associated with the kinematic configuration of the robot arm. ಎರಡು ಟೈಪ್ ಇರುತ್ತೆ, ಒಂದು ಜಾಯಿಂಟ್ ಪ್ಯಾರಾಮೀಟರ್, ಒಂದು ಲಿಂಕ್ ಪ್ಯಾರಾಮೀಟರ್, ಬಿಕಾಸ್ a robot is made up of links and joints. Okay, so for every joint there are 4 kinematic parameters, out of which only one is variable, remaining 3 are fixed. Which is that variable? Theta is variable for a rotary joint and it is remaining 3 are fixed. D is variable for a prismatic joint and remaining 3 are fixed. So the diagrammatic representation of the joint parameters, link parameters merge it up, and the 4 definitions you have to merge it up: theta k, d k, a k, alpha k. Theta k is defined, the joint parameters are defined with respect to z axis, link parameters are defined with respect to the x axis. After you perform theta k and dk ಏನಾಗುತ್ತೆ ಎರಡು ಫ್ರೇಮ್ಸ್ ಮರ್ಜ್ ಆಗುತ್ತೆ. After you perform ak and alpha k are reverse, again the two frames will merge. Okay, so this is how you define the joint parameters and the link parameters. ಆಮೇಲೆ ಜನರಲ್ ಲಿಂಕ್ ಕೋಆರ್ಡಿನೇಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ದಟ್ ಜನರಲ್ ಲಿಂಕ್ ಕೋಆರ್ಡಿನೇಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ is gives a information about how the coordinates are transformed from one frame to the another frame, from the frame k to the frame k minus 1. If I want to transform the coordinates from frame k to the k minus 1 frame, you have to perform four operations. Which are the four operations? Theta, d, a and alpha. So this is equivalent to merging the two coordinate frames twice, once with respect to the joint axis, once with respect to the x axis. Okay, you have to gives rise to a screw transformation matrix along x axis and z axis. ಅವು ನಾಲ್ಕು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಒಂದು ಜನರಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರುತ್ತೆ. That general matrix is tk to k minus 1. So how do we define that? Is defined as tk to k minus 1 is defined as the coordinate is a general link coordinate transformation matrix which transforms the coordinates from frame k to the frame k minus 1. Okay, so you go on giving values for k. So k is equal to 6 ಕೊಡ್ತೀರಾ, ಏನಾಗುತ್ತೆ t6 to 5. ಆಮೇಲೆ 5 ಕೊಡ್ತೀರಾ t5 to 4, 4 ಕೊಡ್ತೀರಾ 4 to 3, 3 ಕೊಡ್ತೀರಾ 3 to 2, 2 ಕೊಡ್ತೀರಾ 2 to 1, then 1 ಕೊಡ್ತೀರಾ 1 to 0. ಇವು ಇಷ್ಟನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ನೋಡಿ, t6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 0, 1 to 0. Sorry, 2 to 1, 1 to 0. The property of matrix algebra is such that when you multiply a number of transformation matrices, all the diagonal indices will cancel each other, leaving you only the source and the destination. Source is t to the power of 6 and the last is t to the power of 0. Correct ಅಲ್ಲ? ಈಗ ನೋಡಿ, t60 t superscript 6 subscript 0 can be written as t1 to 0, 2 to 1, 3 to 2, then 4 to 3 ಹಂಗೆ ಎಲ್ಲ ಡಯಾಗ್ನಲ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬಿಟ್ಟು ಸೋರ್ಸ್ ಡೆಸ್ಟಿನೇಷನ್ ಬಿಟ್ಟಿದೆ. ಸೋರ್ಸ್ ಯಾವುದು? ಟಿಪ್ ಪಿ, ಸಿಕ್ಸ್ತ್ ಫ್ರೇಮು. ಬಾಟಮ್ ಯಾವುದು? 0. So that is that t6 to 0 gives you the orientation of the last point with respect to the base. If this matrix is given as input to the robot goes and stops at that particular point. ಅಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ಆಬ್ಜೆಕ್ಟ್ ಇಳಿಬೇಕು. ಈಗ ನಾವು ಟಕ್ ಅಂತ ಹೋಗ್ಬಿಟ್ಟು ಟೇಬಲ್ ಮೇಲಿರೋ ಒಂದು ಕಪ್ ತಗೋತೀವಿ, ಡಸ್ಟರ್ ತಗೋತೀವಿ, ಪೆನ್ ತಗೋತೀವಿ. ಅದೇ ರೀತಿ ಒಂದು ರೋಬೋಟ್ ಹೋಗ್ಬಿಟ್ಟು ಅದು ಕಪ್ ಎತ್ಕೋಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ತೋರಿಸಿದ್ನಲ್ಲ ನಾನು, ಅದ ಹಿಡಿಬೇಕು ಅಂದ್ರೆ ಇಷ್ಟೊಂದು ಸರ್ಕಸ್ ಮಾಡಬೇಕು, ಇಷ್ಟೊಂದು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಮಾಡಬೇಕು, ಇಷ್ಟೊಂದು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಅನಾಲಿಸಿಸ್ ಮಾಡಿ ಅದು ಅಲ್ಲಿಗೆ ಹೋಗಕ್ಕೆ ಎಷ್ಟು ಥೀಟಾ ಕಂಡುಹಿಡಿಬೇಕು, ಎಷ್ಟು ಆಂಗಲ್ ಕಂಡುಹಿಡಿಬೇಕು, ಅದನ್ನೆಲ್ಲ ಇನ್ಪುಟ್ ಮಾಡಿ ಪ್ರೋಗ್ರಾಮ್ ರನ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಹೋಗಿ ಅದು ಕಪ್ ಎತ್ಕೊಂಡು ಬರ್ತದೆ. ದಿಸ್ ಈಸ್ ಹೌ ವಿ ಡೂ ದ ಪಿಕ್ ಅಂಡ್ ಪ್ಲೇಸ್ ಆಪರೇಷನ್ ಯೂಸಿಂಗ್ ಅ ರೋಬೋಟ್. Okay, so these are the three important parameters what we have done. One is how to attach the frames, the kinematic parameters and the general link coordinate transformation matrix. Okay.